Projectiles chapter, as you know, and I'm just going from the beginning. So last lesson we just went from the beginning, and the key bit was when we're resolving horizontally there's no acceleration, when we're resolving vertically the acceleration is gravity. And all the exercise 6a that we did were where we were projecting horizontally from a height. So that's really what we worked through last lesson. Okay, so these were the examples, and then we did 6a. Now, 6b really leads into 6c, and it's very straightforward, so I don't propose that we actually do exercise 6b. I mean, we'll turn the pages, but I want us just to go on and spend our time on 6c, which will build in all the skills from 6b. Okay, so all we're saying in 6.2 is that as we start projecting from the ground, all right, that's what we're going to be doing now. Remember, before we were projecting from up the cliff and projecting horizontally, we're now projecting from the ground and we're throwing the ball into the air. And what we're saying here is, just like many, many times in mechanics, you can break down that initial speed into its two components. Its horizontal component, that is obviously adjacent, so that is going to be u cos the angle, and the vertical component, which is opposite, will be u sin the angle. So nothing new there. We've done many times before, we've been breaking down forces, so diagonal forces, into the horizontal and vertical components. And then really all we were doing in this chapter is just practicing breaking those down. Okay, you can just see we're just breaking these back. So there we were told we were going 3 along and 5 up. So we were just using a bit of SOHCAHTOA and Pythagoras. Okay, just looking at the exercise here. All right, we were projecting at 25 at an angle. We just had to go and work out that the horizontal component was 25 cos 40. The vertical component is 25 sin 40. Easy peasy. I really don't want us having to do this. Again, you see question 2. That's all we were doing. We were breaking down this going downwards diagonal initial speed into a horizontal and a vertical component. So had you been doing this exercise, you can see that's all we are doing. Now, of course, if you want to go back and do these, please do. But I think this was at a very basic level, and I would rather we spent our time on 6c. So you can see all of these is just a bit of SOHCAHTOA, a bit of Pythagoras. Okay, there again, SOHCAHTOA and Pythagoras, SOHCAHTOA and Pythagoras, and then we're on to where I want us to spend our time. Now, you may have seen in my introduction, I think we should, when I say my introduction, the sentence that incorporated where I scheduled this lesson. But I propose today and tomorrow that we work our way through 6c. Okay, so this is a big exercise. This is the core part of the chapter. Then on Wednesday and Thursday, we work through 6d, and if you've got time, some of the mixed exercise. We will then, what I'm proposing to do, I will then set the topic test as an assignment, and you just try and get that done over the next week or so. Okay. We'll move on. We won't wait until the assignment's done, but I'll just set it there. You upload it when you're done. So anyway, today and tomorrow we're going to be looking at this key bit where we're projecting at an angle. Now, various bits and bobs to remember. Remember when you launch something into the edge. Remember when we were launching things straight upwards, that we were saying right at the top, when you got to the very top, just before you start coming down, just at that point where you're at the maximum height, your velocity equals 0. So given that we're breaking down this projection into its horizontal and vertical components, when we're looking at the vertical components, okay, at the greatest height, the velocity is equal to 0. So that's the key point. A bit of terminology here, all right? The horizontal distance you travel, so not the total distance, not the total distance the ball's gone, but if you launch it from here and it lands, sorry, I'm just seeing a bit of a lag. Yes, if you launch it from there on the left and it lands over on the right, then that horizontal distance is called the range. And obviously the greatest height is the greatest height, no big deal there. And remember the symmetry of this. there will be times, this point at the bottom in purple, do note that the time that you take to go from the initial projection to the top of the bounce is the same time as it takes to go from that maximum height to hitting the ground again. So do bear in mind that symmetry. Okay, so again, I just want to hook out the key points from example 6 rather than we spend ages on it. So when we're resolving vertically, as I said, at the maximum height, the velocity is 0. Another key point, okay, from the point of view of the resolving horizontally, resolving vertically, you never, given that you start projecting it from the ground and it finishes with the ball being on the ground, your total displacement, okay, is 0. Okay, when the particle strikes the plane, it is at the same height, 0, as when it started. So just be clear in your mind why these are the case. When you resolve vertically, maximum height to velocity is 0. At the end of the journey, your displacement is 0. And then part C, just like we were doing the other day, remember when you're resolving horizontally, there is no acceleration, so the distance equals speed times time. I think those were the key points. We then, obviously, these are just variations on a theme. Example 8, 7, and 8, and then and 9. So I would like you, please, to get on with exercise 6C. So it's a big exercise. So you've got all of this lesson and all of tomorrow's lesson to work through it. What I propose to do is to stop the recording now. Obviously, I'll stay on for the whole of the lesson. If you want to keep cameras on, or I will unmute, that's totally fine. But I'm here expecting you to say, please, can you go to question 2? Please, can you go to question 3 and all of that stuff, just like we're in a normal lesson. Okay, so I'm just about to switch off the recording, stop recording.